You are welcome to GMAETS 41's class. Today is Wednesday, as you all know, and by the GMAETS 41's online class timetable, we have chemistry today. We are going to be dealing with this part of chemistry, the mole and percentage composition by mass. That is what we are going to study in this class. Appealing to you to manage the lights condition. Yeah, I'm using lights from our power company who are never serious, because they like messing somebody up. Just imagine a moment ago there was light, but you just cannot see clearly. That's so funny and annoying. All right, our dear friends in the university here in Nigeria, and because I got a wonderful news from my students of those that took JAM, the last JAM. Yeah, the last JAM. Admission is running in now, and especially for those of them that applied to Nnamdi Azikiwe University. Super happy to hear of many of you being admitted already on merit. That's wonderful. Meanwhile, you want to be patient, right? Want to be patient for the usual nonsense celebration in this country between some members of the university and the government. I think on Monday, there was this 2 weeks warning strike. It's a festival in the country already. It's a festival. So bear up with them as they continue their, serious attitude. Meanwhile, get serious, because whatever becomes the result of the strike action, once you get back to school, lectures will begin. If they decide to drag the strike until perhaps months, you come back, it's just examination. So make sure you are up and doing, start studying. And on this platform, GMAETS 41's channel, all the things you need in your course term courses, they are available. Okay, so make sure you always stay tuned. We're going to move on straight to look at the concept of the mole and then percentage composition. Before we define the mole, I would like you to understand the concept, because the mole is actually an amount. The mole is actually what? An amount. Now I have this. You can see this carton, and you see clearly that inside we have some things, we have some stuff. So this thing is just like a mole. Now you notice that the mole is an amount. Let's say this is 1 mole. But let us start with this, because we are going to define what 1 mole of a substance is, or a mole of a substance. You're expected to know the definition. Now you observe that this substance, which I am referring to as a mole of substance, contains some things inside. We refer to those things as elementary entities. There are many of them. One can actually get those elementary entities, you see, right? Don't mind me, these are my elementary entities. But anyway, as we move on in this class, you get to know what elementary entity of matter is. So this amount contains some particles, some entities inside. Now the entities it contains, right? The amount of the entities are linked to the quantity, or to the amount of entities, the amount of atoms that you have in carbon-12. What this mole contains, right? The entities it contains is compared to the entities, to the number of atoms you have In carbon-12, this scale of measurement is quite important that you take note of it. Carbon-12, because in our last class when I defined relative molecular mass, relative atomic mass, okay, that's relative molecular mass and relative atomic mass, we still compared that number to carbon-12. So carbon-12 is always our basis of comparison when we're talking about the measurement. So what have we actually gotten so far from this simple illustration? The mole is an amount, Now that mole contains some entities. We call it elementary entities. You can see them inside, right? And that the elementary entities you have, the number of elementary entities, the amount, the quantity of the elementary entities, always compare to the number of atoms in carbon-12. Can we now define the mole? I want to believe you have your writing materials there. We define a mole of a substance or 1 mole of a substance as an amount that contains many elementary entities as the number of atoms in carbon-12. You know, when you talk about carbon-12, we have 12 grams in it. So a mole of a substance is simply an amount that contains as many elementary entities as we have 12 gram atoms in carbon-12. I'll write the definition on the board. The mole, or let's say a mole of a substance, a mole of a substance, is an amount that contains as many elementary entities as there are exactly as there are exactly 12 gram atoms in carbon-12. So this is what a mole of a substance is. It is an amount. Take note of that. That is why usually, sometimes if it comes to formula, whenever we are referring to the mole, we refer to it as amount also. The mole, refer to it as what? Amount. It is an amount, okay? And then it contains as many elementary entities as there are exactly 12 gram atoms of carbon-12 or in carbon-12. Now we have defined what the mole is. What are the elementary entities of matter? You're expected to know them because an examiner can ask you to list the elementary entities of matter. Now, the elementary entities of matter include atoms, molecules, ions, electrons, and any other particle, particles. So we are asked to list the elementary entities of matter, you can list this: atoms, molecules, ions, electrons. okay, that form elementary entities of matter. What is the base formula of the mole? Which of course we are going to refer to as amount. Meanwhile, take note, the short form of mole is MOL, still pronounced mole. So I'm going to give you the formula, base formula of calculating the mole. I think in our previous class, I actually brought out that formula when I introduced the concept of molar mass. So the mole, which I shall refer to as amount, is equal to, we're going to use N for it, is equal to mass of a substance divided by mass of 1 mole of that substance, which is molar mass, divided by molar mass. We shall use capital letter M for molar mass and then small letter m for anyhow mass. That is mass of any number of moles. This m here represents mass of any number of moles apart from 1 mole. Because in our previous class, if you're talking about mass of 1 mole, this is what you use. We call it molar mass, mass of 1 mole. But you see this mass? I simply put, just say anyhow mass. It does not include mass of 1 mole. This is mass of any mole of a substance except 1 mole. So you want to take note of that. This M could be mass of 2 moles. It could be mass of 5 moles. It could be mass of 0.3 moles. It could be mass of 0.1 mole. It could be mass of 0.008 moles. This one is not mass of 1 mole. Mass of 1 mole refer to it as molar mass. So this is the base formula that you want to take note of. And we call this equation 1. We call this equation 1. Permit me to check the network situation. And then we continue. Of course, nothing seems to be working where we find ourselves. The board is blurry. This could be network. Please hold on a moment. Let's see. Let me boost the network and see what happens. The network is good, right? But it seems to be shaking, as in, can observe the screen shaking somehow. Let me see. Let me see what happens. I just hope it's still shaking. All right, you're going to manage the situation. You're going to manage the situation. Idrissa, thank you for appreciating the class. You're welcome to join us. Chinedu, the network is good, all right. Thank you for informing me. Let's move on, please. I just observe the camera is just shaking, but the fault is not from camera. I think it's perhaps the network situation. Sometimes it happens, and I used to notice that its network is shaking somehow. I don't know from your end anyway. Don't know from your end, but I think we could still manage that, okay? Now, let us continue the class. You want to take note of this formula. There are other relationships that amount or number of moles have with other things, which you're expected to know. And I'm going to give it to you here as notes. Notes. See, I'm meant to divide the board here into 2, but I wouldn't do that. I wouldn't do that. Notes. 1 mole of a substance is equal to the molar mass of that substance. Molar mass is equal to molar mass. 1 mole of any substance is equal to what? Molar mass. You want to take note of that. 1 mole of any substance is equal to molar mass. And that is also equal to Avogadro's number. Avogadro's number. Avogadro's number. You want to take note of these. And that is also equal to molar gas volume. Molar gas volume. So you want to take note of that. This relationship. 1 mole of a substance is equal to the molar mass of that substance. In our previous class, I already taught you how to calculate molar mass, the same way you obtain relative molecular mass. Now, 1 mole of a substance is equal to molar mass. It's also equal to Avogadro's number, and it is also equal to molar gas volume. Now, you want to take note of this. Avogadro's number. Avogadro's number is a constant. The value is equal to 6.02 times 10 to the power of 23. Sometimes we quote it as particles. Then you want to take note that molar gas volume is equal to 22.4 dm cube. If you want to convert from dm cube to cm cube, you multiply by 1,000. So this is also the same as 22,400 cubic centimeter. This relationship, please don't play with it. Do not play with it. Are you following, right? You should have it at heart, because you use it a lot to do calculations in chemistry. Is that clear? We are moving on. Once again, let me check the network situation. Okay, this is a bit stable now. I think I will come to the screen and say this. The bad light condition. It was actually the evil light condition that was causing that, blinking. I noticed. See, these evil people that give us, what is it called? Power. EEDC, Enugu Electricity Distribution Company. Every time they will be giving someone light that is doing like this. It's just so annoying. But anyway, they can't get to me. Let's move on. GMAETS 41 is never affected or frustrated by that level of evil. Let's move on, please. Take note of all these things. And of course, with all these concepts, everything about the mole has been summarized. I can ask you to calculate the number of moles in maybe 5 grams of a particular substance. If I ask you to calculate the number of moles in, say, 5 grams of a particular substance, it's simple. If you like, you use this formula. If you don't want to use this formula, you can use this guy. Can use it. If you remember in our previous class, where I taught the concept of relative molecular mass and its calculation, and then introduced molar mass, I told you, friends, that this molar mass, yes, hear the name molar mass, it is simply mass. It is simply mass. So one can use this relationship to actually solve problems that this formula can solve. Because this quantity you're seeing here is still mass. Mass of 1 mole. So if I ask you maybe to calculate the number of moles in, say, 5 grams of calcium trioxocarbonate 4, for example, all you just need to remember is that 1 mole of calcium trioxocarbonate 4 is equal to the molar mass of calcium trioxocarbonate 4. And if you brainstorm, crack your brain, activate the network of your brain, remember that in the previous class, we calculated that calcium trioxocarbonate 4, 1 mole of it is 100 grams. That is the mass, which means 1 mole of calcium trioxocarbonate 4 is equal to 100 gram mass. Now, I am asking you, how many moles are there in 5 grams of that calcium trioxocarbonate 4? CaCO3. We usually call that guy CaCO3, in those days, CaCO3. So if I know that 1 mole of calcium trioxocarbonate 4 is equal to 100 grams as a mass, Therefore, how many moles is equal to 5 grams? You cross multiply and play with that mathematics. You play with that maths. Now, I want to say this clearly, please. An excellent knowledge of direct proportion, direct variation in mathematics. I repeat, an excellent knowledge of direct proportion, otherwise known as direct variation in mathematics, is required to actually play with calculations in this part of chemistry. You're going to see that as we move on. All right, I'm done with the mole. Is that okay? Let us now introduce percentage composition by mass. Meanwhile, before we move on into that, this concept, we might not solve questions on all of them today. As a matter of fact, this class is, divided into 2 classes or 2 sessions. This is part 1. Are you following right? In part 2, we'll go into more details of how we use this relationship. Of course, we'll be talking about mass-mole relationship, mass-volume and mole-volume relationship. Yeah. So this is much like an introductory class to it, and I will solve just some little questions. Please let us talk about the concept of percentage by mass now. I want to believe you've copied what is on the board. If not, remember, at the end of our live classes, a copy of the live class is always made available. So you can come back to retake the lesson and copy your notes. Percentage composition by mass of an element. What is it? Percentage composition of an element. Like the name goes, or the term used for it, percentage composition. So simply, it is the percentage of a given element in a given compound. A compound is chemically formed when elements combine. A compound is formed when elements combine chemically. So when these elements are combined, what is when they are combining? When these elements are combining, what is their percentages in that compound? That is what we refer to as percentage composition by mass of an element in a compound. So you can put down the definition. This is the percentage of an element, also expressed in mass, in a compound. So I give you a compound, for example, tetraoxosulfate 6 acid, H2SO4. I can ask you, what is the percentage of oxygen in that compound? So the amount of oxygen, the percentage of oxygen in that compound, which can also be expressed as the mass of the oxygen in that compound. That is what we refer to as percentage by mass. Are you following right? Percentage composition of an element in a compound is simply the percentage of that element, which is also expressed in mass, in a compound. Does that make sense? So let us assume that I give you a compound and we have an element X in it. How do you calculate the percentage composition by mass? Take note that this is usually expressed in percentage anyway. Percentage composition of element X. Okay, let me just say of X, where X is the element in a compound. If you want to obtain it, is equal to RAM of that element, RAM of X. RAM of X Let me write the x this way. Let me write the x this way, small letter, because I want to use multiply times its atomicity. RAM of x times atomicity of x divided by relative molecular mass of the compound containing x. Once you do this, multiply it by 100. 100 over 1, of course, in percentage. Simple. Relative atomic mass of that element x. Multiply it by the atomicity of that element x in the given compound. Then divide it by the relative molecular mass of that compound that contains x. Whatever you get, express it in percentage by multiplying by 100. This is simply how we obtain percentage composition of an element. We call this equation 2. We call this equation 2. So there are two basic equations, right, that we're going to deal with in this class. If you have any question on this, you can drop your question in the comments box and I would respond to you. I'll respond to your question. Meanwhile, as you join, please like this class and share the link. Share the link to this class to your friends, to your classmates. Encourage them to join this class. 3 times a week, GMAETS 41 comes live to teach your friends. Monday, Wednesday, Friday, from 8 o'clock p.m. to 9:30 p.m. Nigerian time, or from 8:15 to 9:30 p.m., or from 8:30 to 9:30 p.m. Is that okay? Within that time. If you are yet to subscribe to this channel, all right, right away, click on the subscription button. After subscribing, you will see a notification bell. Click on that notification bell. A menu will pop up. Select all. Select all. The reason for that, anytime I come on live, you'll be the first person to be notified, right, by YouTube that we have class. Or if I upload any video like I regularly upload, you will receive a notification for that so that you can learn. Remember, no time. Thanks to technology that, despite the challenges we are facing in our academic or educational sector in this country, there are many people out there doing their best, teachers, to give you the best. Make the best use of the opportunity so you can become who you are meant to be academically in future days to come. Right? So don't allow anything happening all around to affect you negatively. Be positive. We are here to help you. You can also support this channel by becoming a channel member on platinum or diamond level. That will be appreciated. It is now time for us to look at calculations, right, on what we have considered so far. We've got some questions to deal with. I'll wipe this part so you can try to round off. Let me check the network situation. Faith David, by this time, I don't think I understand your statement anyway. If fail Monday, so I'm preparing for jam, so that's good, that's great. Please continue to do your best, put in your best effort. Are you following right as you prepare for the jam? Once again, irrespective of some challenges created also by the board sometimes. Yeah, by jam board sometimes. People should not allow any of this to discourage you. Besides, as it stands in our country, these bodies have been made to be the ones in charge of your exam, your professional examinations. Always take it seriously. Are you following right? And I'm pleased to inform you that the GMAT 41 is always giving the best to students. Just our previous jam, yeah, our student that blast very well, did excellently well. We were able to ace 350 from this platform. And I am pleased to inform you that students have been given medicine and surgery, yes, from Nnamdi Azikiwe University. So, and kudos to many others who have been admitted also. This platform is here to help you, friends. If you're preparing for JAM, start early. Our classes are in progress always. We don't wait for anyone, because that exam, your professional examinations as they are professional, irrespective of whatever happens, right? Or whatever had happened. These exams cover 3 years scheme of work, from SS1, SS2, SS3. So it's not funny to prepare for this exam within less than 1 year. So make sure you regularly follow up with GMAT 41 and you will be covered. Yes. If you have questions, ask. I will respond to your questions. Okay? Now let us move on, like I said, to solving questions. I'm going to wipe what we have here on the board. I think I can wipe this also. So I've got this question here. I'd like us to deal with. I'd like us to deal with it. And the question reads, it's a JAM question actually, 2012. It's a JAM question, 2012. I think I have to copy it. JAM 2012. And this is what we've got. How many atoms are present in? How many atoms? How many atoms are present in 6.0 gram of magnesium? Permit me to abbreviate of Mg. That's magnesium. And here in bracket we have Mg equal to 24, and we're given capital N to be equal to 6.02 times 10 to the power of 23 per mole. Per mole. This is Avogadro's number. This is Avogadro's number. This is Avogadro's number. On this platform, you are taught and well taught first, and then we consult these professional exam questions. So that by the time we start solving them, you will understand what we are doing. Okay? So this is 1 plus 1. Have that in mind. Nothing is there. It's simple. Now, if you look at this question, what are we looking for? We are looking for the number of atoms that are present in 6.0 gram of magnesium. So what do? You have to remember a standard first, or remember the standard rather. And the standard was that thing I wrote here, which I told you not to joke with. That 1 mole of a substance is equal to the molar mass of that substance. Is also equal to the Avogadro's number. And it's also equal to the molar gas volume. Avogadro's number deals with number of particles, like I said, number of atoms, because these particles refer to either atoms, mole, electrons, and, ions. So anytime you're exposed to a problem like this, just smile. Go back to the basis, to the foundation. And what is the foundation? 1 mole of a substance is equal to, so we know that 1 mole of a substance, 1 mole equal to the molar mass of that substance. Molar mass. Since we are talking about number of atoms, how many atoms? You are meant to link it to Avogadro's number, because it is Avogadro's number that deals with number of atoms, number of particles, number of molecules. Avogadro's number. Do not forget that these things, they make up your elementary entities. Atoms, molecules, ions, and I said electrons, other particles. Is that okay? Now, in that relationship I gave to you, your Avogadro's number is what covers for all these number of particles. If we know this condition, now go back to this question. Take note that the quantity given to you is mass. You can see the unit. So you must convert this thing and work in terms of mass and Avogadro's number. So what do? 1 mole of magnesium, what is its mass? 1 mole of magnesium, 1 mole of Mg is equal to 24 gram. This is the molar mass. Yeah, the formula mass. That reminds me, molar mass is also called formula mass. Take note. Just that formula mass is more general. Molar mass is specifically used for compounds. Formula mass is now general, both for atoms, for ions, for compounds, right? For radicals. Call it generally formula mass. If you use the relative atomic mass times the atomicity and you sum them together, like you learned from our previous class. So, like I said, 1 mole of magnesium, this is the mass, 24 gram mass. I don't need to write in the mass anyway, since I've written gram. The unit tells us that already. And this is equal to Avogadro's number 6.02 times 10 to the power of 23. 1 mole of a substance that has this mass for magnesium, this is the number of atoms that are there. Since we are being asked number of atoms, I'm going to write these as atoms. Now, if we know by standard that 1 mole of magnesium has this mass 24 gram, and that mass is equivalent to this number of atoms, this number of particles, this number of ions, this number of molecules. So this mass now, 24 gram, contains this number of atoms. Therefore, how many atoms will be there in 6.0 gram? So I'll just write. It implies that 6 gram is equal to, you don't know. You don't know the number of atoms that are contained in 6 gram of this magnesium. But you know that 24 gram of that magnesium contains this number of atoms. It is a standard. That's why I told you when I wrote it here that you're expected to memorize that relationship. You don't play with it. You don't. So from standard, 24 gram of magnesium, a mass of 24 gram, which is the molar, the concept of molar mass. 1 mole of magnesium will contain this mass. This is the number of atoms that you have there. Therefore, 6 gram of that magnesium, how many atoms will you have? So this is a direct variation, concept. All you just have to do is to cross multiply. If you cross multiply, what will we have? X will now be equal to 6 times 6.02 times 10 to the power of 23. You are meant to divide it by 24. Cross multiply first and divide both sides by the coefficient of what you are looking for, which is 24. And that is going to give us how many atoms? 6 here is going to give you 1. 6 into 24 will give you 4. I hope I'm correct, right? Your basic knowledge of multiplication is very much important for you to be able to handle division. You meet something like that. So this 4 we divide this 6.02. Let's see. 4 can go into 6 how many times? 1 time. Remember 2. Attach the 2 to this 0. So you have to put your point. If I fix 2 here, I will get 20. 4 can divide 20. How many times? 5 times. No remainder. You come here, 4 can divide 2. How many times? Of course, you reduce this. 2 divide 2, 1. 2 divide 4, 2. So you're using 2 to divide 1 there, which is going to, of course, give you a 0.5. But anyway, let us work it out. 4 can divide 2. Is it possible if you have 2 over 4? It's not possible. So you record 0, right? Then the remainder will still be 2. So that remainder, which is 2, attach 0 to it, you get 20. Divide that 20 by 4, you get 5. So if 6.02 is divided by 4, right, you should be getting 1.505. Now you're going to multiply it by 10 to the power of 23. I've told you don't need to miss our classes, so you learn all of these things. Your basic maths, if you have challenges with it, remember where to follow GMAETS 41. You can follow GMAETS 41 on our channel, specially dedicated for basic scholars. That's GMAETS 41 basic class. That's the name of the channel. You can confirm we have 6 times 6.02. We are dividing it by 24, and this gave 1.505. So I'm correct by what I did. This is the number of atoms that are there in 6 grams of magnesium. We can conclude, therefore, there are 1.505 times 10 to the power of 23 atoms in 6 grams of magnesium. Of course, we have the options here. Option A, 1.20 times 10 to the power of 22. Option B, 2.41 times 10 to the power of 22. Option C, 1.51 times 10 to the power of 23. Option D, 3.02 times 10 to the power of 23. Clearly, the correct option is option C, 1.51 times 10 to the power of 23. Remember, you can approximate this. You can round it off from these 3 decimal digits to 2 decimal digits. You know, that's it. We are done with this question. If you have any question, you can ask. If there's anything you do not understand, you can ask. Ifeoluwa, sir, please, which course do you study? Sir, I'm going for mechanical engineering. You really know maths a lot. Sir, the best. Thank you very much. Monday, I appreciate. I really want to be like you. I learned, sir. Well, Monday, I appreciate your commendation. You're wanting to be like me. And the interesting thing, I must assure you, friends, is that you can even be better than I am. That's the truth. You can. It's just about you following up what we're doing. Take your studies seriously. Why I say you can be better than I am is, yeah, age-wise, I am far, far older. So I'm getting old. I'm an old man. Right? And you know, as we go on, normally strength is going down. So you friends take up from where we stop. And because of technology and the fact that knowledge abounds, you friends have the opportunity of learning even newer things than those of us that are getting older. So you can do better. I must be honest, I don't know how anybody might see it, but of course, that's the truth. I am far better than so many people that have taught me. But of course, I respect and appreciate them because they laid the groundwork. So what am I trying to say in essence? I am not underrating anyone, no. I'm not looking down on those who have taught me, who had taught me before, no. What I am saying in essence is newer generations can even be better than those of us before. So while you aspire to be like me, I'm assuring you and encouraging you that you can even be better than I am Monday, okay? I'm glad that you friends are learning from this platform. That's just the most important thing. Let us move on to the next question. Meanwhile, you stated that you want to study mechanical engineering. That's wonderful. I think I love the course. I studied chemical engineering anyway. Studied chemical engineering, okay? Mechanical engineering is a super course also. Okay, we are going to take this next question. We're going to take this next question. Question number 2. This is question 1. I think the way presented this, I should have written question 1 first, then indicate the exam. Question 1. JAM 2012. Jan 2012. So that's the exam body. Now let us look at this next one. So question number 2. Question 2. Still JAM. This is JAM 2018. 2018. I hope this has not cut off from view. Let me check, please. Let me check. Here, we'll adjust the camera a bit. Fine. JAM 2018, and this is the question. What is the mass of 4 moles? Right? No, that's not the question. The question is how many moles are there? How many moles are there in 40 grams of sodium trioxocarbonate 4? How many moles are there in 40 grams of sodium trioxocarbonate 4? We're given certain things here, which of course is the right of students to be given the relative atomic mass of the substances. I've said this from our previous class. Relative atomic mass of sodium is 23. It's the right of students to be given this. Yes, by standard of examination. However, I encourage you friends to memorize as many relative atomic mass of elements as possible, because sometimes human factors could cause it, and the examiner may forget to give you this relative atomic mass of the element. Meanwhile, you need it to use in solving question. So we've got this. How many moles are there in 40 grams of this guy, So it's simple. They're asking us how many moles are there in 40 grams of sodium trioxocarbonate 4. Sodium trioxocarbonate 4, Na2CO3. All you have to do is go back to the standard. That is one thing you can do. And what is the standard? For me, I prefer that standard I wrote here, which I wiped and I told you don't joke with it. In fact, I love that relationship than the main basic formula of the mole that I gave you. That formula where I related amount to mass over molar mass. I prefer that overall relationship to that formula, because that formula just gave you one little knowledge about the mole. Yes. It didn't give you other information about the number of particles, about molar gas volume. It did not. That formula amount equal to mass over molar mass only related number of moles to mass and then molar mass. What about you're given a problem about volume? What about you're given a problem about number of atoms, number of molecules, like this question number 1? That is why I am telling you to give serious attention to that overall relationship I wrote here. Are you following right? And then have excellent knowledge of your direct variation in mathematics. I think with these 2 guys, you're good to trash any question in this part of chemistry. And there is no exam you sit for in chemistry that you won't be tested on question from this part. That I am telling you for free. So what do we do? Go back to the standard. Once again, you want to recall that 1 mole of any substance. So I'm going to say 1 mole of sodium trioxocarbonate 4 is equal to 106 grams. 1 mole of sodium trioxocarbonate 4 is equal to 106 grams. That is the molar mass. 1 mole of any substance is equal to the molar mass of that substance. In fact, let me write this as molar mass before fixing the value. Is equal to molar mass of sodium trioxocarbonate 4. Okay? Therefore, we are asked, how many moles are there in 40 grams? Let me bring out the values for this now. So based on this, we know that 1 mole is equal to the molar mass of sodium trioxocarbonate 4. From our previous class, you know how to calculate it already. 23 times 2 plus 12 times 1 plus 16 times 3. You get 106 at least. This one, I don't use to forget it is here. There are certain things you just have to know apart. Are you following, right? But you can calculate it. I already taught you how to find molar mass from previous class. It's the same as the way you obtain relative molecular mass. The difference is that molar mass has unit, grams per mole, which you can still quote as gram. But relative molecular mass does not have unit. So from standard, this is what we have. 1 mole of sodium triisocarbonate 4 will be 106 gram. 1 mole sodium triisocarbonate 4 equal to this. Therefore, how many moles will be there in 40 grams? How many moles are there in 40 grams? You don't know. Cross multiply. Of course, when you're cross multiplying, you know that this gram will cancel out, because it's just like dividing here, the left hand side, dividing the right hand side, and then picking one equality sign, which is now going to be 1 mole over y, where y is the unknown, the number of moles that are there in 40 grams, equal to 106 over 40. 106 grams over 40 grams. The unit we cancel, because you are not calculating mass here. The unit of the masses we cancel, you can see that. And then you'll be left with the unit mole. So that once you get your final answer, you know that it is mole you are looking for. It's just like even this number 1 solved. This gram will also cancel, since you know the two masses. What you are looking for is number of atoms. So that at the end of everything you solve, you get the unit as number of atoms. So that's pretty cool how simple you solve this. You know that from here, y will be equal to cross multiply, divide both sides by the coefficient of what you are looking for. So this is going to be 40 divided by 106. 40 over 106 will give you what? I can actually solve that without calculator, but I just want us to be fast. I might choose to reduce it by 2 if I want. 2 can divide this 20. 2 can divide 106. You get 53. Okwaya? Is that not so? And now, if this guy actually gives you, where will I show that? Because I'm trying to tell you, you can work a lot of things out, without your calculator. If this thing actually is going to give you 20 over 53, 53 can go into 20 how many times? 0 times. This one is just basic maths. 0 times. You put your 20 divided by 53 is 0, because 53 cannot divide 20 ordinarily. So it will be 0 remainder 20. What do you do to that remainder? Attach 0 to it, you get 200. 53 can go into 200 how many times? From what I'm seeing here, 4 times 5 is 20, so it should be more than. So we talk about 3 times. 3 times. That 3 times is going to give you 159. Yeah, because 3 times 53 is 159. So that you can get the remainder to be 1. So 200 divided by 53, it's going to be 3 times. You put your point 3 times, so you have 0.3, the 1. That remainder 1, attach 0 to it, you get 10. Attach 0 again, because you need to now attach a number of 0 that can produce something, a number that can be able to be divided by 53. So if I say remainder 1, when 53 divides 200, 3 times remainder 1, right? Is it remainder 1? No. 200 minus 159 is not remainder 1, it's remainder 49 rather. Remainder 49. That 49, attach 0 to it and divide by 53 again. And 53 can go into 490. If you have 49, attach 0, 490 divided by 53. 53 can go into 490 how many times? Can check. 9 times should be more. I think that should be 8 times. So I would take this to be 0.38. 0.38. But let us find out. 40 divided by 106, 0.3777, approximately 0.38. Of course, that's it. No time to waste. Can do a lot of things with this thing that God has given to you. And I believe you friends can actually cope. This is 0.38. Therefore, 40 grams of sodium triisocarbonate 4 Please take note that this is the first one we solved. 40 grams of sodium triazocarbonate 4, right, is equal to or contains 0.38 moles. Contains 0.38 moles. So that is it. We are done solving this particular question. I think this is sufficient for now. Like I said, this is part 1 of this topic, because there are still other calculations involving the mole that you should learn, especially those involving chemical equations. The equations have to be balanced before you solve problems on it. Don't worry, next week, Wednesday, when we'll still have our next chemistry class, we'll be dealing with that part 2. Round off so that I can wipe the board. Let's take our last question supposedly. Let's take our last question. Question number 3. Question number 3. Question 3. Let us see JAM. See what we've got here. This will solve questions on the mole. Let us check for that one on percentage composition by mass. Okay, I've got this question. This is JAM 2003. JAM 2003. And the question is, what is the percentage by mass? What is the percentage by mass of oxygen? In Al2SO4 3 dots. Now have this water of crystallization attached. Then in bracket Al equal to 27. Al equal to 27. We have S equal to 32. H equal to 1. And then O equal to 16. Let us see how we solve this. Meanwhile, for this guy, let me read out the options, please. Let me read out the options. You can follow. Option A for this particular question, 0.83 mole. Option B, 0.38 mole. Option C, 5.26 mole. Option D, 2.65 mole. Of course, the correct answer is option B, that is B, 0.38 mole. Okay, so back to this guy, which of course is going to be, should we take this as our last question or second to the last? At least we solved 2 on percentage composition. But all these things are simple maths. There's no big deal. Meanwhile, I think this is going to be our last question. If you want to learn more on this concept of the mole and percentage composition, go to the playlist on this channel. If you playlist, search for Chem 101. Chemistry. Everything about chemistry is there already. So you can actually search out this topic there and learn more about the mole and percentage composition. Let's solve this as our last question. What are we looking for? The percentage by mass of oxygen in this compound. So what do we do? You know the formula already. Percentage by mass of any element in a compound is the relative atomic mass of that element times the atomicity of the element in that compound, then divided by the relative molecular mass of the compound containing that element, multiplied by 100. So I think what I would like us to do first is quickly calculate the relative molecular mass here. But before then, I want to know that RMM, let me give you the formula first, just as a reminder. Because once you know the formula that solves something, the formula will now guide you to know the things you need to know. You need to determine first before you calculate the main thing you are asked to find. So percentage by mass, which is the same as percentage composition of any element, of an element, let's say X, is equal to RAM of X times atomicity of X. Oh no, I need to provide a space for times 100. Times atomicity of X divided by RMM of compound. Permit me to abbreviate compound like this, containing X, then times 100. Take note that this is multiplication. This is multiplication. Perhaps let me use a different color of marker, even if times, then times. Now from here, we are looking for the percentage by mass of the element oxygen. So X here represents oxygen in this question. Relative atomic mass of oxygen is 16. So we're going to multiply it by the atomicity of oxygen in this compound. Now, how many atoms of oxygen do we have? It's just for you to check. Here, you have 12 atoms. You have what? 12 atoms. And then here, you have 2 atoms. Because these 2 will multiply the invisible one that you have here. We give you 2 atoms. Okay? Then divided by the relative molecular mass of this compound. What is the name of this compound even? We go. I've taught you how to name a compound already when I taught you trinary compounds. This is aluminium tetraoxosulfate 6. Aluminium tetraoxosulfate 6. They have these 3 here. Doesn't change the name. Still remain that sulfate 6. Dihydrate. Because we have 2 waters of molecule there. So let us look at the relative molecular mass of this compound. RMM of Al2SO4 3 2H2O is equal to, sadly, I don't have this at heart. I've not memorized it. Of course, you're not meant to memorize all of them anyway. Let's go. This is going to be, aluminium is 27 times, how many atoms do you have here? 2. Plus, you come here. This is sulfur. This 3 is affecting sulfur there. So sulfur is 3 atoms. Sulfur is 32 as relative atomic mass given. Multiply it by the 3 atoms. Then plus, you come over to oxygen. It's oxygen here. How many atoms of oxygen do we have? Okay, oxygen is relative atomic number of oxygen is 16 times. This is 12 atoms. 12, because this 4 is going to multiply this 3, giving you the total number of atoms of oxygen here. Is that okay? So solve for this part and then add it to what you have here. This is going to be 2 times this number of molecules, 2 times hydrogen is 1. Of course, for water, I don't need to waste time. Let me just write it 18. No time. If you calculate the relative molecular mass of water, it's 18. Hydrogen is 2 times 1. That is 2. Plus oxygen, which is 16. Whatever you get here, if you have 16 plus that 2, that is 18. 18 is the relative molecular mass of water. Multiply it by the number of molecules. Then add it to all these things. Let us work this out quickly. This is 54 already. And then we have 54. 54 plus, this times this is 96. Plus 96 plus, this is 16 times 12. Right? So let's see what we've got here. 27 times 2 is 54. Add it to this term. Add it to this term. So it gave me 342. That 342, add 18 times 2 to it, because 18 times 2 is 36. 36. This is 378. So the relative molecular mass of aluminum tetrasulfate 6 dihydrate is 378. All you now have to do, it implies that the percentage by mass of oxygen will now be equal to, how many atoms of oxygen do we have all together in this compound? The relative atomic mass of oxygen is 16 times the atomicity of oxygen in this compound. Let us check. How many atoms of oxygen do we have all together? From here, we have 12. We have 12 here, 4 times 3. And here we have 2, 2 times 1. 4 times 3 is 12. 2 times 1 is 2. Add it, because you're meant to add whatever I have here to this one, right? If you add it, you're going to get 14. So the total atomicity of oxygen in this compound is 14. 4 times 3 plus you add the number of atoms in water that you have for oxygen, which is 2, like I said. 14 is the total number of atoms of oxygen. Divide it by 378 and then multiply by 100. 16 times 14. Divide by 378. This is 0.59259 and multiply by 100. So we get 59.26 approximately. This is equal to 59.26%. 59.26%. That is the percentage by mass, percentage composition by mass of oxygen in this compound, aluminum tetraoxosulfate 6 dihydrate. All right. I hope you've learned something good from here. So you see that it's pretty simple. There is nothing difficult to do here. Nothing is difficult. Now pay attention to the options. Option A, 14.29%. Option B, 25.39%. Option C, 50.79%. Option D, 59.25%, which of course is what we have here, 59.2. I approximated 26. From the calculator, it's actually 59.25, but it's actually 259. I decided to approximate. Are you following right? But 59.26, 59.25 as you have in option D, they're still the same. And of course, I have taught you how to carry out calculation involving some mole concept, and of course calculation involving percentage composition. This is the full way of solving percentage composition problem. There is no other thing there. Once a percentage composition by mass question is given to you, simply apply this formula: relative atomic mass of that element whose percentage by mass you are asked to find. The relative atomic mass of that element, multiply it by the atomicity, divide by the relative molecular mass of the compound containing that element whose percentage by mass you are looking for. By the time you're done with that, multiply by 100%, by 100 rather, and then your problem is solved. So it's very simple to deal with this guy. Nothing is there. I don't need to solve any other question for you to follow through, because every other question is handled the same way. Like I said, if you want to learn more, by tomorrow evening per se, God willing, right, I will drop a link in this particular live class. Yes, I'll drop a link on the screen. You can tap on the link. It's actually an end screen. Tap on it. It will take you to another full concept of percentage composition and the mole concept, where you can still learn more, because we have a pre-recorded video lesson that have been uploaded to it on this channel. But like I said, in the playlist, you have it there on this channel. Just look for chemistry, Everything in chemistry is there, including your organic chemistry, okay? Full-blown works. Now, the only thing left for us to treat more are calculations on the mole. In part 2, we are going to see more of that, where we link the mole to, volume. And then we apply the knowledge of the mole to solve problems involving balanced chemical equation. That, of course, is stoichiometry. So get ready as we move on into that in our next class, stoichiometry. You wouldn't want to miss that next chemistry class next week, Wednesday, by 8 o'clock p.m. to 9:30 p.m. Nigerian time, West African time. To get updates on this class, of course, what to do is simple. It's free of charge. What to do to get information about it is free of charge. Subscribe now. Subscribe now. Subscribe now. After subscribing, turn on the notification bell. Turn on the notification bell. You just have to click on the notification bell. A menu will pop up. Then you will see all. Select all. By default, YouTube will select personalized, but that will not give you all the notification anyway. Select all so that YouTube would give you all notification once anything is available on this channel for you to learn. Then please, like I said, remember to support this channel, okay? You can become a channel member on platinum or on diamond level. To do this is simple. Below each of our video, you will see the join tab there. Click on the join. The platinum level or the diamond level appears, whichever that is convenient for you. Select that to support this channel. That will give you access to all our classes. To give you further benefit, if you have questions, you can contact me as a channel member. I will respond. Becoming a channel member will give you access to certain other classical video lessons specially made for our channel members. Apart from our normal monthly membership, which is the platinum and diamond, it's on monthly support, okay? Apart from that, you have the one-time support, which you can do at your convenience anytime. To do that, below each of our video, you'll see the thanks icon. If you click on that thanks, YouTube will provide you with, list of whatever you can support your creator, your favorite creator with. Okay, so you can send GMAETS 41, a super chat, a super thanks, super stickers, in whatever amount that is convenient for you, as you may see on the list provided whenever you click on that thanks icon. Share our video lessons as well, to share the links to people. Leave comments, like it. These are other various ways you can support GMAETS 41, and that will be very much appreciated. Thank you for connecting to this class. We are done with our class today. We thank God for that. I'll be seeing you in our next chemistry class on chemistry. However, remember, on Friday, we're still having our live class on physics. I'll be rounding off scalars and vectors in that next class with calculations involving multiplication of vectors. Don't miss that class. I'm going to teach you the two methods of multiplying vectors: the scalar or dot product method and the cross or vector product method of multiplying vectors. In fact, in that class, especially in the second method, cross product, you're going to learn something wonderful about how we apply the knowledge of matrix 3x3 square matrix determinant approach to obtain the cross product of two vectors. I'll be seeing you live on Friday. But before then, remember, lessons will continuously be uploaded to this channel. Our biology is fully in progress. However, that is on pre-recorded video lesson. Tomorrow, I hope to release a lesson on the concept of the 5 kingdoms of living things, and then discuss the characteristics of virus as a living thing and virus as a non-living thing. Make sure you get the update on that biology class tomorrow. I'll be seeing you live on Friday for physics class. Bye.